So I hope everyone is able to find, I'm seeing a lot of you have now the textbook. Okay, that's good. And I hope everyone have your slide through the Hanyangin web server, right? People who have, I still got a couple of emails that I cannot find the materials on the web. Yes, there is. And if you have still having troubles, then you can ask your friends, please. And you can print out if you want. It doesn't really matter. You can just wanted to see a PDF version of it. That's good too. So I hope everyone had a good week last week and good weekends. So what did we discuss last week? Last class? What did we start discussing? Algorithms, yes. Well, do we know what algorithm is now? Yes and no, I guess. Yeah, no. I agree. It's not something that you can explain. Like I said last class, it requires a lot of practice from this time on. So I haven't given you the assignment 1 yet, but they will keep asking you to write or read a different type of algorithms and see whether you can practice on top of the given algorithms since we start discussing on the assignment. Assignment 0, I ask you to find 3 companies. I also get a couple of emails. Smaller, better. What I mean by smaller, better, I wanted for you guys to look for up some venture companies with some interesting technology. Like I also mentioned consulting companies, but usually consulting companies are not small, very big ones too, right? So it's okay. And you can also select one from consulting, the other 2 from ICT. Doesn't really matter. Any combination is fine. Keep asking me about the formatting. Just one paragraph, it's okay for one company. Just describe what they are doing on your own terms. And maybe you can express a little bit on why you think it's good technology or why you think this company will disappear soon, just like most of the venture companies. So anything is fine. Just general report on just introducing me a interesting companies, technologies. That's it. So no rush, no push. It's okay. So just relax and try to do as a fun assignment, okay? Back to the algorithms. And we start discussing very stupid algorithms like adding numbers. And kind of stop talking at the point where we briefly introducing some of the introduction of the computer histories and stuff. And he was involved in Manhattan Project. What is Manhattan Project? Just for curiosity. Making nuclear, atomic bomb, not nuclear, atomic bombs at the time. So he actually proposed the general architecture of computers, CPU, memories, and most importantly, they actually said that computers back here, they didn't have any program instructions. So nowadays, if you turn on your computer boots itself, has OS somewhere in the computer, it boots. Back then, no memory. So every time you need to do something, you have to do something, rewire, or if you want to say reprogramming every single time. 아까 여자들이 막 탁탁탁 막 이랬죠. So you have to do this every single problem before you run the computer. But he changed the idea. So von Neumann, we're gonna cover a little bit later when we're touching the computer organization chapter, and his architecture will come up again. Anyway, I just wanted to show you this ENIAC. Again, you don't need to memorize all this. I don't care what year the ENIAC came out, but just some of the history of this computer was born in the war times, was strictly military applications, and then it goes to more of a general purpose use, general purpose programming, blah, blah, blah. Von Neumann here again, store program computer. ADVAC is somewhat like next version of ENIAC, but it's okay. But things to know for the common sense. just this computer start having a program inside and run without reconfiguring every single time. 혹시 anybody have experience in 8-bit computers? 16-bit computers? 아 진짜? 32-bit computers? Oh. Yeah. When I was at elementary, there was 8-bit computers that also can play games, and then it goes after that. Then they start calling the computers 32-bit, 64 bits. They have different names like Intel's later on, and it's okay. Anyway, that's the thing that you should consider. 이렇게 많이 불렀지, 뭐 8비트, 16비트, 32비트 이러다가 갑자기 무슨 64비트까지 부르다가 갑자기 펜티엄 이렇게 막 부르기 시작했죠. 네. 원래는 정확한 이름은 그렇진 않아요. 펜티엄은 하나의 브랜드 이름인데 그렇게 넘어갔죠. 사람들 일반적으로 많이 부르게. So modern computer since 1950 to present, the current time, computer was there, blah blah blah. Second generation, Fortran and COBOL. Anybody hear this programming languages? It's also programming languages that could do a mathematical computations. Some people still using it. I'm not the one. COBOL is usually used in a banking systems. Still, the core banking systems, they do write the program in COBOL, very old programmers. And then after this point, there is a job called programmer. They start hiring a programmer after this point. I think if you do a COBOL now, if you know how to do it, there might be a better chance to get a job in those companies too. Then I'm not so sure how much is used at current days. So mostly a computational purposes, solving a mathematical formulas, make it easy, do it faster, do a large mathematical equation in short time. That's the first purpose of having these machines back then. I'm skipping most of the stuff because it's not important, right? Third generation, fourth generation, I don't care. I don't care. The things to look at, software, the term they start using the software because at this point we know how to store programs into computer memories. So they start building programs. So the term software came out and software engineering techniques are being discovered. And next generation internet, simply put, network of computers. I think one of the chapters will cover some of the history of the internet. But do you know what was the purpose of having an internet at the first place? Army too, yes. Internet is actually coming from some project funded by US Army, DARPA project. It was actually built as a military network because back then they were fearful of a nuclear attacks. So in case the nuclear attack happens and they still wanted to be connected between people. So internet is actually having those background when they actually first architectured. Anyway, very smart people. I know one guy who actually into those projects. He's very old now. 근데 those guys are genius. 근데 아시는 분 중에 아시는 분이 아니지. 같이 일했던 연구소에서 계시던 분이 그 처음 인터넷 설계하고 있던 사람 중에 한 명인데 사람이 아니에요. 얘기를 해보면 다른 외계인들이야, 외계인들. 되게 똑똑하신 분들이더라고. Anyway, mails and stuff. Don't worry about this too much. Again, do not memorize these generations. I don't care about histories. I care about algorithms, how to look at algorithms, solving problems, and how you can develop from it. It's not our interest, but I just mention it because our textbook is briefly touching this advances in computing. I'm speaking fast because it's not important. So this is my style. So if you see the slide, I don't spend too many minutes on that particular slide, then it means there's a less chance that I would ask questions from those slides. Okay? 하다 보면 내가 좀 빨리 지나가는 슬라이드도 있을 거고 그러면 내가 빨리 지나가면 아무래도 시험에서 물어볼 가능성이 좀 적겠죠. 별로 중요하지 않을 수도 있고. 그렇죠? Anyway, this is a summary of what we discussed last class, including a little bit of today. Computer science is study of algorithms. Algorithm is well-ordered collection of unambiguous, again, unambiguous, right? Clear, effective computable operations. We did also discuss 3 different set of operations, right? What was the 3 different set of operations that we discussed? Sequential, conditional, iterative. So I'm going to keep asking you these type of questions throughout the course. So what if I ask you, what is sequential operation? Write down, explain it briefly. 그럼 어떻게 해? Huh? Yeah, but not in Korean, right? But probably I'm going to ask you to write a, explain to me in English, right? It's a rare case, but I will ask such questions for bonus, as a bonus. If we can specify the algorithm to solve a problem, then we can automate its solutions. Probably chapter 12 is covering a theory that anything you can write into this type of algorithms, then there is a solution to it. If you cannot express this, then there is no solution for it. There are problems in this world that doesn't have a solution. I often bring up the example of a 택배 아저씨, delivery 아저씨's problems. Formally there are something called TSP problems, but what is the problem with a 택배 아저씨's? Every morning they have to plan where to go first. What are their purposes? Delivering as many as possible in short time, right? Can you write an algorithm to schedule, to maximize the delivery? It's not easy problem to have an algorithm, right? You have to consider the size of the delivering goods, the distances they have to travel, traffic. Maybe between 12 and 1 in the afternoon, there's a lot of cars on the street, right? Too many factors. And even if you can come up with the algorithms, there's no guarantee that your solution is the one. Right? Similar, that's more of a practical problems, but there are many problems that you cannot have one algorithm to solve. Those stuff is there. So don't get it wrong. If you know how to write an algorithm, it doesn't mean that you can solve everything. Right? That's usually misconceptions that first years have. Anyway, computers developed from mechanical calculating devices to modern electric marvels of the miniaturization, whatever that means. Simply put, the mechanical calculator that we briefly saw, also addition process was there. Those stuff is now translating into those 0-1 ways. Right? So they could be digitalized, the computers that you can use on. Anyway, we're going to keep discussing on the algorithms for today too. Have you guys start flipping the pages on chapter 1? 혹시 책 펼쳐본 사람? Yeah, not yet? Raise your hand if you start reading your textbook. Already? Too fast. Maybe this week. Maybe take a look at it. Maybe starting from this week, I'll be happy to see. But I know some of you will never start reading your textbook anyways. But my warning messages are, you have to read it anyways for the midterms and final exams. So start early is good for you. I mean, especially chapter 1 and 2, there's nothing much. Later chapters will require more things that you don't have enough time. How many courses do you guys take this term? 몇 개나 들어요? How many courses do you take this term? 몰라? 7? 7, 8? How do you sleep at night, huh? How do you sleep at night? Anyway, chapter 2, a little bit of chapter 1 as well. Representing algorithms. Again, examples of algorithmic problem solving continues. Different examples. I also ask you to think about your showering algorithms, isn't it? Didn't I do that last class? When you take a shower in the morning, try to write an algorithm of how you actually doing it, right? Like one of those examples for shampooing your hair in the first chapter, right? So chapter 1 just introduced the concept of algorithms and algorithm problem solving. This chapter develops a more fully notion of the algorithms and algorithm problem solving. Mostly they're gonna start introducing new terms like pseudocode. Pseudocode. Am I speaking too fast? 그죠? Slow down. Representing algorithms. Pseudocode. This language that we speak at this moment is something called natural language that we speak at this moment. We speak the language in respect to grammars. I have to make a speeches following to English grammars. Or if I speak Korean, then I probably say it right in Korean grammars too. So that's your natural language. And there are nowadays many applications that try to understand the natural language in your computer program. Anybody using a iPhone? Do you use a Siri? No, because they're dumb, right? Usually it's not very accurate, I should say. Not dumb. Dumb is not the right word, because we say stuff in natural language. Whatever we say, like we talk to Siri like we're talking to the friends. So usually it doesn't work because they don't do it. Problem of using natural language to representing algorithms. Without even looking at this, what is the problem of representing algorithms in natural language? Ambiguous. It's not clear. And people will understand differently. That's not something that we want when we write a program. Or usually, why do we need an algorithm in the first place? Of course, we discussed it, but another reason that we looked at is usually working together with people. You're working in groups. If you try to build one algorithm with two of your friends, right? Discussion helps, of course, but it's usually clear that first one write the algorithm and exchange algorithms between them. Then you could have a much more clear communication between your friends. Natural language can be extremely verbose, which means many words. 은는 이가. That's too much. Have you counted how many 은는 이가 in the language that you speak every day? Do we need that in the computer programming or algorithms? Probably not, right? Make it precise is the first step. Lack of structures make it difficult to locate specific section of the algorithms. If I try to describe that addition algorithm that we looked at, the carry bits and maybe a single paragraph, then can you spot the looping section? Can you spot the looping procedure within that long paragraph, which I will show you? Natural language is too rich in interpretation and meanings. Just too many interpretation is possible by many others. So they will understand differently. That's not something that we want. There's a lot of joke that if you know how to read the 법정 같은 거, law books, everyone interpret differently. 그죠? 법전 이런 거. Computer science, engineers. If you one interpret differently than the other, that's a serious problem. Like the examples that I show you in the first class, that rockets. That happens in early 1990s. There's also recent cases for NASA was failing. They lose some robots in somewhere in Mars. What was the problem of it? Anybody know that case? They were working together with some British company, the US, NASA. English, they used a pound and feet. NASA used meters and kilograms. Simple mistake. They lose a couple $1 billion somewhere in the sky. 최근에 그런 일도 있었죠. Because they communicate in words. Even though they communicate in the documentation, they weren't clear about those units, right? We wanted to avoid such cases. Algorithmic is usually a good way to prevent that too. Yeah, that's too much, but still eligible. Okay. This is a one-paragraph description of a addition algorithm that we studied last week. Good? I probably stopped reading it after second sentence. Bored. And it's difficult to see which is the crucial part of these algorithms, right? If I give you this, you can write the algorithms, but it will take some time. And some people will understand slightly differently, misunderstand some part. Then you might have a different algorithms that doing a different stuff. That's not something that one wants, right? So in this chapter, mostly we're gonna look at how we reduce this wordy paragraph into a more of an algorithmic like, which we already saw from last week's class. Natural language not sufficiently precise to represent the algorithm like the ones that we saw. Pseudocode, it stays something between the natural language and algorithm. So pseudocode is a simpler way of writing down algorithms. Maybe it's better to translate natural language, translate the pseudocode to a program than translating natural language to a program. So it's a step between to do this. Pseudocode is used to design, represent the algorithm, a compromise between two extremes of a natural and formal languages. Natural that we know, what is a formal language? At this point, you can think of it as program. Program looks weird to you, right? Weird to you. Formal language, if I put it in simple ways, then we break it down into components according to the grammars. So it's even also look like programs that you see. The pseudocode stayed in the between. So it's a good transition from natural language to formal representations. Like this. This one is more of a high-level programming language. I don't know which program is this, but this look like a program. It doesn't look like a pseudocode, but some people actually prefer pseudocode even in this way too. Let me take a look. It's the exact same example that we saw. Okay, whatever this does, int I am carry. There was three variables, three positions that we need to compute two addition, right? There's an to a0, bn to b0, right? It seems this time n here is a 100. It's a 100-digit number. It's adding of two different 100-digit numbers. C is your result, right? Adding A and B. Okay. M, I don't know, maybe next integer. While j goes to m minus 1, do something. Carry is 0, do something. I don't know what they actually do. But if you know how to read this, then you might have an idea of the part. High-level programming language usually is not the good way to express the ideas between your friends because it also requires a different interpretation. Maybe one of your friends is not good at programming, so they misunderstand a certain sentence in this part. So That's why we need pseudocode in the between. If you start doing any programming assignment, write a pseudocode and translate into languages or whatever language you do. And then you submit, you forget about it about a month. And then you try to look back into your program after about not even a month, after 2 weeks, you forgot what you did. I guarantee you, you have to study your own work again in order to understand what you did. Usually that's a programming, it's difficult. But if you have a write down a pseudocode, it's much easier to follow. 나중에 하다 보면 프로그램 짜놓고 한 몇 주만 안 보면 자기가 짠 건데도 처음 보는 것 같아. 누가 짰냐 이렇게 물어보는 사람들 흔해요. 자기가 짜놓고. 또 보고 다시 이해를 다 해야 되니까. 수도코드는 그 중간쯤에 있는 거라고 보면 편해요. 나중에 수도코드를 보면 대충 이런 식으로 돌아가게 짰구나 라고 기억이 나기도 하거든요. Actually, if you work for the company, you actually fight a lot with your co-workers because everyone is blaming it on each other. This part you wrote it. No, I didn't do it. This part you wrote. No, I didn't do it. Turns out you actually did it, but you forgot it because. Yeah.
Do you have an example of pseudocode?
Pseudocode, yes, it's coming up. But you already kind of saw from the last slide that we have. Set A into certain numbers, so set I into 100. That's very similar looking as a pseudocode. There is no single definition, there's no one general definition how the pseudocode look like. But as long as it's short and simple, we consider that as a pseudocode like. 질문할 수도 있지 그럼. 그죠? Questions good? 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 잊어버렸다. 어디 있는지. Okay. Again, sequential operations that we saw. Basic sequential operations. Within the sequential operations, you can do computation, input and output. Computation, maybe adding two numbers, A plus B. That's also type of sequential operation. Input, you're getting an input from the users. Or output is what? Printing C, maybe value of the C. Instructions for performing computation and saving the result. Set the value of the variables to arithmetic expressions. What does that mean? It's not clear yet. But what does it mean to have variables like int I? Like shortening for integer. 뭐야, 가? Integer. Oh, let me just write it integer. Integer I. What does it mean? Now we know it says we're going to call I as some value of integer. I didn't give the value yet, but it's quite straightforward, right? As we see it, we know what it is. That was also one of the requirements for the primitive operations that we discussed last class, right? They called it as a primitive operations. You go, what am I doing at this point? A little bit of computer organization. But 뭐 하는 거예요? 여기서는? Yeah, I'm telling the computers that in your memory, I'm gonna call this position I. I am having my storage. This place, okay, I. Okay, it means that I'm gonna here reserving my position in the computer memory to be exact. Okay, that's what they're doing. Set the result, set the variables in this way. Variable is stored location that could hold a data value. Location right here, we're going to call that as I. Data value in this case is 100. Very simple way of doing stuff. Of course, later when you're actually doing this type of more advanced courses, this is not exactly what's happening. There are other things also happening, but at this point, this is good enough. Okay? 정확하게 이렇게 되고 이렇지 않아요. 나중에 다른 좀 더 고학년 과목을 듣게 되면 이렇게 하기에도 뭐 중간에 뭐 여러 가지를 해야 되고 하는데 지금은 메모리 안에 i라는 데에다가 내 값을 쓸 수 있구나라고 이해하면 돼요. Pseudocode, not precise set of notation rules that can be memorized, rigidly followed. It's not the natural language, but it's precise, more precise than the natural language. But it's not 100% algorithms. It's not 100% programming. So there is still a gap. Some people look at the pseudocode, they look at it differently. There's still a chance, but there is a less chance comparing to the natural language. Input operations submit to a computing agent data values from the outside world that may be used in later instructions. Output data send result from computing agent to the outside world. What does it mean to have an outside world in this case? They show you some result. After adding A and B, show the result of the C, because C is the location where we store the addition of A and B. But what does it mean to showing the values to the outside world? Yeah, print on your screens. Whatever written on this memory, we cannot see into the memory, right? I need to bring it up and show it to my screen. That's simple as it is. I know sometimes your textbook discussing this look like a very, very difficult stuff, or something is not beyond this course, but they're actually referring to a very simple steps that you use every day. Display on your screens. That's what it means to whatever showing you, whatever prints out from the memory into a screens. So you can see it. Input operations. I'm giving a value of A and B. That's it, nothing much. Okay. First setup, pseudocode. Well, I can still call this as a pseudocode. Okay. At least they have steps, 1, 2, 3, 4, 5, sequential operation. And they call it operation. It looked like a natural language, but it's less word. So, let's see. This particular algorithm is also a very dumb algorithm. It's nothing more than 재능수학, again. Average miles per gallon algorithm. I know none of you have a car, or some of you have a car, I don't know. Anybody has a car? Driving license. Ooh. Right after high school? 그죠? I think I got my first driver license when I was 16. 고1 때 딴 것 같아. 그럼 뭐해? 차가 없는데. It doesn't really matter. Yeah. So, or motorbike. 오토바이 타는 사람. It's okay. Average miles per hour. So I just wanted to find out how much it goes my car for given 1 gallon. 1 gallon is what, 3 point something liters? 미국은 갤런으로 하니까 I don't know. Miles is 1 mile is what, 1.6 kilometers. Doesn't really matter for what we do. So first operation, it says get values for gallons used, starting mileage, ending mileage. Asking for input, right? Get value. Simple, get value of 3. Right? Much more clear than when I explained to you in natural language. So gallons used, I have 10 gallons in my car. Starting mileage, my car has been 2 years old, so mileage of my car is maybe 6,000 miles. Ending mileage, I don't know yet. Right? Maybe if I have one, maybe after using 10 gallons, I know my mileage is maybe 6,040. I don't know. Set the value of distance driven. Set the value of distance driven to ending mileage minus starting mileage. How do you calculate the average per gallon without even looking at this? Whatever I have now, whatever I had before, how much gas that I used. Simple subtraction divided by the number of gallons. That gives me the value, right? 간단한 거잖아. 빼기해서 나누기 하면 땡이죠. 그죠? So set the value of distance driven by. So let me just call it as distance. I'm just simply translating the pseudocode into ending mileage. I'm gonna call E mile minus S mile. Done. Maybe above here, distance. Give me any number, maybe 50, I don't know. Int E mile. 몰라, any 4,000. 아니다. Yeah, 4,040. Starting mileage 4,000, whatever. Set the value of average mile per gallon to distance driven. So average mile is distance divided by what? Gallon used. Oh, I need gallon somewhere here too. Int gallon. I don't know, 10. Right? This 연비, 그죠? 쉽게 연비. Show it to the world. Print the mile. Average miles per gallon. Print. Done. Return. Or they call it as stop. Program. Pseudocode. Pseudocode. Right? Better pseudocode, much easier to go to the program. See? It's very similar example that we saw from last class too, right? But back then we didn't mention anything about pseudocode. Right? Good. If you can't do this, then you have a serious problem. 이거 못하면 안 되겠지, 그죠? But that was a very straight line forward, straight line algorithm. Just step 1 to 5, very straight. They didn't have any loops, or they didn't have any conditional statement. They don't ask me if something is average miles per gallon is 10, then good average, bad average. They don't have it. So from that, into that pseudocode, the very basic pseudocode, maybe we can add more functionality to it using this statement. Control and conditional question asking operation, they often use the expressed in if something is bigger or smaller or equal to, do something, otherwise do something else. Right? Conditional statement. What can you do? What can you add to that very basic algorithms? 여기다 물어보고 싶으면 what do you do? Let's try to add a control statement, if statement. What can you add? You want it to be this pseudocode more fancier. 이건 지금 너무 dumb-하니까. I don't know. Maybe you have certain values to compare. If the average miles per gallon is more than 10 miles per gallon, then print out your car is good. Smaller, then print out your car is bad. Do something else. Go fix your car. Maybe that's another way of adding if statement. What about loop? Can you add any operation using loop in this pseudocode? Well, what happens if you do it once in this program? Program dies, right? Maybe you add a loop somewhere in here, keep asking again and again without killing the program. Maybe you can use the loops that way too. Let's take a look. Like I told you last class, if and else. Don't worry about it too much. But it's an operation, asking operation. Whatever this box, you can actually do this. Each line. They say something called Boolean Conditions. Didn't mention Booleans yet, but it will come up in next chapter. Boolean operate Boolean conditions, but I can see that if you go into right, false. If you go into left, true. Maybe that's Boolean operation. It's asking whether something is true or false. How does it represent it to a digital way? Yeah, true 1, false. 아니다. True 0, 1 false. Doesn't really matter which way you want to map it. It will come up anyways. So, bit fancier example right here. It's almost same. They print out the values, then add the extra condition like if average miles per gallon is greater than 25. 이거 뭐야? 아이고. If average miles per gallon is greater than 25. Okay. Instead of killing it, like 다음 시간부터 이런 거 안 쓸래. 귀찮아. 이거 너무 쉬운 것 같아서. 너무 여러분들을 무시하는 것 같아서 다음 시간부터 이런 거 쓰지 않겠습니다. If I average usually G, okay, G, average miles greater than equal to 25. Okay. Doing what? Yeah, print. 뭐야? Getting good mileage, good. Else? Doing what? Print. You are bad. You're not good. Done. Stop. Return. Those of you who doesn't have any programming experience, you just wrote your first small program that doing an average computation. 이거, if you just write it down in C program, your program will be running. If you try to write that into C program, they have no idea what they're talking about. 그죠? You can translate into any other language. Python looks very similar but slightly different. You can look it up in the internet for that particular operation. Maybe in Python they don't call it as a print. In C maybe it's printf or something. Names are slightly different, but translation is almost, the procedure is almost same. That's your first program right there. Loop, repetitive task. We discussed this too. Continuation conditions determine if the state is true or false. Like those examples that we saw last class. What was the example? If I is less than equal to some value, but if you change that inequality signs in opposite ways, that condition not met, which means it's going to be always true in that loop. Never going to stop in that loop. Infinite loop, right? Your condition will never stop, never give you false data. So, it's a slight different version. It's almost same. While loop, how do they do it? 이거 while loop 어디 갔어? 여기 있다. While loop. I skip few slides. I'm gonna come back to it. While they declare while your response is yes, continue to do this. If your response is going to no, then you break it out. What's inside? Exactly same what you have, but you just wrap around everything into while loop. 여기에 while이 있어서 wrap around everything. So they're gonna keep asking you until your answer, your output, your average gases per mile is satisfactory. 미안, 몇 개를 스킵했네. 이거 뭐, we know this. They just put extra lines. So another simple loop operations only, but you guys know this already anyways. Loop examples. Step 1 to 3 operation, set the value of count to 1. Some valuable name now is count start from 1. While count is less than equal to 100, do step 3 and 5. 3 and 5. Set square, some variable named square, to count. 뭐야? 아유, 너 왜 이렇게 잘 못 쓰냐? Square. Count times count. See? Put the value of count and square. Print count, print square. Let me just follow this for maybe a couple of times. Count. Okay, that's my pseudocode. Okay, when I'm starting, count is 1. Okay, while count is 100, do step 3, 5. My still count is 1. I'm still less than 100. Okay, go to step 3. Set square. Square. Oh, shoot. 스펠링을 잊어버리네. Oh, that's a brain activity not good today. Square. 아이고. Count times count. Okay, then it's 1. I hope everyone can do this. Print value and count. Values of the count. Count, still 1. And square, still 1. Add 1 to count. So at this point, count is what? 1 plus 1, 2. Go back up again. Checking again. Count is less than 100, still less than 100. Square. 2 times 2, right? 4. 2, 4. Count at this point, 3. Continue. 3 times 9, 3, 9, 4. Next. Very simple example, but many of you will prove your program working in this way. You'd like to find out which values they have in your program. Luckily, if you know how to use those nice tools, then they actually keep track of these values. You don't have to do this in your hands. You can just simply click and see what's the current value of it too. So that's a simple way of doing the debugging. There's nothing to debug. Debugging means you're fixing your programs, finding anything wrong with it. So what does it do? Every single time it's doing a, what is square? 제곱. Yeah, it's a simple program that does a square operations. But it's just doing for every number from 1 to 100. So if I print out, then I'm going to keep getting this 1, 1, 2, 4, 3, 9, 4, 16, 16. Go, 8, 8, 64. 아닌가? 맞지? 어휴. I need my calculators. Anyway, they do that for 100 until they reach counts reaching 100. When they're hitting the 101, they're not going to print it out, right? So that's how you keep track of the operations inside. Slight different operations. So there are two different ways of writing down this loop. That particular loop, the previous one, is checking this condition at the beginning of the loop. Right? Every single time I hit here, they checking whether the count is less than or equal to 100. Okay. Sometimes you can put this condition at the end of the loop. That's completely okay. That's way of doing stuff. Sometimes you can just break out the loop if you wish. You don't have to wait until reaching 100. So there are instructions that you can actually do it too. So two different ways of doing it: pre-test loop and post-test loop. What is a pre? The word pre, beforehand. 그죠? Post, after. So testing your loop conditions before you start. Continuation conditions is tested at the beginning of each path through the loop. Post-test loop, continuation condition is tested at the end of the loop body, somewhere within, almost ending up before stop maybe, not the beginning. Okay. Is it important? No. It's your styling. I don't really care. As long as it works, as long as we never go into infinite loop, you're okay, right? 그죠? 가끔가다 이제 컨디션을 까먹는 경우가 많죠? 컨디션 까먹으면 어떻게 된다? 안 돌아간다. 자기 혼자만 계속 돌고 있겠죠. Primitive, like we know, instructions that computing agents understand capable of executing without further explanations. 다 지웠네. int I 100, easy to see. Primitive operations. Addition is also type of primitive operations. I don't need to explain. It's already built in. So it means that your program understand what this means. It's already been programmed within your language. Okay. 아니면 플러스 사인이 뭔지 어떻게 알아? Okay, so pseudocode way of writing stuff, different formats. They recommend this instructions, construction ways. In your textbooks, they say computation, set the value of variables to something. Input, get the value, print the value of something. And conditional, if something is true, then else. Looping, they recommend while and put down your conditions here and do whatever. This is what they recommend in your textbook as a pseudocode format. If I ask you an assignment to write a pseudocode, it doesn't have to look like this. It's okay. If you think that your way is much more less wordy, less words and more precise, then it's okay. Okay? It's not something that we have to follow. It's okay. You can ignore it if you don't like this. But just don't write it like a natural language way. I'm not looking for reports like your assignment 0. It's not something that I want. I want to understand of your ideas, solving problems. Examples of algorithmic problem solving. From this page on, they're gonna give you 4 different problems they wanted to solve. The first few problems are nicely explained. Easy to write down pseudocode. Like this example 1 is explaining some algorithm called, they wanted to build this algorithm of doing this, go forth and multiply. So condition is like this, given to non-negative integers. Non-negative integer is 뭐야? 양수? 음수 양수에서 양수? Non-negative integers. A and B, but condition A and B must be greater than or equal to 0. And compute an output product of something called A3B. They just define some funny stuff. Using the techniques of repetitive additions. Doing what? That is, determine the value of sum of A plus A plus A plus A for B times. I don't need to explain, but it's quite clear. So if I write down, let's say A and B must be greater than 0. I'm going to say A is, give me some nice value. 2, B is 5. So 2, 3, 5. It's giving me what? Well, give me an algorithm of doing this. Can you do this? 이건 하겠지, 그지? It's quite easy at this point. It's not so much different from that looping example we just saw a couple of slides ago. 그지? 그지? What is the dumbest way of doing this? Dumbest way? Not the dumbest way. Let's forget about pseudocode. 3 그냥 it's some symbols. if I do this, it's okay too. Just some symbols. Yeah, I always wonder why we have to put 3. Next time I probably change it, but they do it in your textbook. So like this, it's also okay too. Multiplication is basically you can do a multiplication using addition operations, right? If you actually take a look at it, the multiplication is using the additions. See? 2 times 5. Okay. How do you do it? Forget about pseudocode or natural language. How do you do it? This step you can just simply go into, okay. I might need a count because other examples always had a count. I'm just copying it. Okay, let's do count. Okay, maybe I can start 0. While count, 뭐야? I need some condition. What's my count should be compared to? 어머? 왜 이래? 뭐 하는 거예요? 뭐 하는 거예요, 라리? 수업하는 겁니다. 이분들이 목 아프게 아주 쉬운 거 벌써 2시간이니까 3시간 동안 얘기했더니 뭐 하는 거예요? 잘못 들었길 바랍니다, 내가. 그 count, okay. In the loop, it looks like I need to do this 5 times or 4 times. Okay, B, yeah. Less than equal to B. It might be easier to start from 1. Okay. What am I doing here? Yeah. Maybe I need to keep add. Let's say if I do this 4 times, 5 times, I'll probably get print what? A. Yeah, because I'm keep adding to A over and over again. Done. You don't need the pseudocode. It's a waste of paper and time. So, like a small tip, if you're not sure about these conditions, maybe you can just write down this overall structure. Then it's a chance you can take, right? Like maybe give you the partial mark. 부분 점수라도 주겠지? 그지? So this is a very simple pseudocode for this. Of course, they checking for extra conditions. What if A is 0? I don't need to go into the loop anyways, right? If A is 0, 0 plus 0 plus 0 plus always be 0, right? So they do just doing extra conditions right here. Check whether A is 0. If it's 0, your product always be 0, right? I don't need to go into this loop again, ever again. If it's not 0, then I should do that. Okay? So what we're interested in this part, set the value of count to 0, set the product. They probably declare another variable. I used A here as a 1, but you can declare another variables. So I'm going to call product. The final output 0. While count is less than B, why is a B? Less than, not equal to less. Because we're starting from 0. 0, 1, 2, 3, 4. Okay? Set the value product to product plus A. Count. And here I should put that as a count. 알아서 끝내줄게. Count plus 1. Count. End of loop. Do this, print out the value. Done. Why do they do this in the beginning? Why do they have a preconditions up here? Even if it's a 0, if you go into here, you'll be wasting your CPU and memory, right? It's extra time. They keep adding zeros. So that might be a good idea to do this. Okay, I'm gonna stop here today. I need to call your attendance now. Any questions for today?